Hi, welcome to section 1 for powers and exponents. Today's target is I can evaluate expressions containing exponents. Please copy that down and then we'll get started. All right, so first we are going to work on identifying what the power is, what the exponent is, and what the base is in 2 to the third. That's how I could read that, 2 to the third. The exponent is the smaller number up above. The base is the bigger number down below. And when I talk about the power, I mean the whole thing. All right? So just a few words that clarify power, exponent, and base. All right, let's look at geometry and exponents. So I hope you would agree that this indeed is a square. Okay, so this blue figure right here is a square. And I know it's a square because this side length has a measure of S, and this side length also has a measure of S. Well, that means they're the same, and we know a square has 4 sides that are the same. So the area of the square, I would say, well, I've got to multiply the side times the side. But in terms of exponents, I could rewrite that as S squared. So I have a base of S squared since I'm multiplying it 2 times. The exponent will tell me how many times I need to multiply the base. So in expanded form, it's S times S. Using exponents, it's S squared, or side squared. Now the volume of this cube, we'll see it's a cube because we have a side length of S, another side length of S, and then we have a height of S. So this is a cube. It's a 3-dimensional figure. So the volume, and we'll write cube, is side times side times side, which is S to the 3rd power, or S cubed. Again, this exponent tells me how many times I multiply the base. And the expanded form is S times S times S. So when we talk about speaking exponents, if I say 4 squared, that's referring to 4 to the 2nd power, or squared. Squared refers to an exponent of 2. 4 cubed, 4 to the 3rd power, or 4 to the power of 3. I can say it also as 4 cubed. Everything else we would say to the power. So if I had, let's say, 5 with an exponent of 7, I would say 5 to the 7th power, or 5 to the power of 7. So 2 different ways to say exponents when they're above the exponent of 3. Let's look at our examples here. It says write the power to represent the numbers or of the geometric model. Well, here it looks like I have a cube. I have one side equaling 5. I have another equaling 5. And I have a height equaling 5. Well, my cube says the volume is equal to 5 times 5 times 5. That's expanded form using exponents, 5 to the 3rd power. Now we can use our calculators to calculate that. And what we'll do is on your calculator, you're going to hit 5, and then there will be a caret button, which brings the cursor up into the spot where the exponent would be. You'll hit 3, and then usually equal or enter, and you hopefully should get 125 units cubed. And we have a label of units cubed because we multiplied 3 dimensions. We multiplied a length, a width, and a height. It's a 3D figure. Let's go ahead and look at number 2. How can I find the area? Yes, I could probably sit there and count all those blocks, but let's make it easy. How could I find the area of the square? Well, first, let's count this side, and then count this side. Let's verify that they are indeed the same. Hopefully you have both sides being a value of 7. And remember, area is side squared, which means area is 7 squared. When you put that in the calculator, 7 caret 2, enter, you should get that area is equal to 49 units squared. And now notice this is squared because it's only 2 dimensions, a side and a side. Now, we have to play some detective work here where we actually have a number and a base and we need to find our exponent. So let's do numbers 3 and 5 at the same time. Then we'll go over and look at 4 and 6. So the base is 8. Remember, that's the bigger number. And then I'm going to put a box because I don't know my exponent, but I know I need to get to 64. So the question is, well, what number goes in this box? This is where you can use your calculator and start to think about your number line in your head. Well, if I maybe try 8 to the 3rd power, I get 512. Well, 64 is way less than 512, so let's try 8 to the 2nd power. If you use your calculator, you get 64, so I know my missing exponent is 2. For number 5, my base is 2. I need to figure out what my exponent is, but I know my number is 8. So you go ahead, use your calculator, try to play around with numbers where you do 2 to the something and get the number 8. Hopefully you've got 2 to the 3rd and you got the number 8. Now let's look over at 4 and 6. Well, this is a little different because our base is -3 and I need to get a -7. So -3 to the something is going to equal -27. When you put this in your calculator, please make sure this negative is in parentheses. The -3 is in parentheses. So same idea. You're trying to figure out what number is the exponent. And when you put -3 in parentheses in your calculator and take it to the 3rd power, you should get -27. Try number 6. We're going to have a base of -5. You find the exponent, but we need a number of -125. Hopefully we got a value of 3 again. All right, so take a look. If the base is negative, like it was here in numbers 4 and 6, it must be in parentheses. I'd like you to write this or type this into your notes. If the base is negative, it must be in parentheses. Let's go ahead and flip the page or turn to the next page, and we're going to see where we may have some examples of why they are negative, okay, or not. I'd like you to go ahead and change, look at numbers 7 and 8 together. Change this exponent to a 2 and in 7. In your calculators, plug these in exactly as they are written. So parenthesis, -5, and parenthesis, and then caret 2. Hopefully you get +25. Now, number 8, I'd like you to plug this into your calculator exactly as you see it. -5 to the second power. You get -25? But wait, when I do a negative, right, this one says -5 times -5 gets me a positive 25. But isn't that the same here? Well, actually, for number 8, what this is saying is -1 times 5 squared. We look at order of operations, and when I think about parentheses, exponents, exponent comes first. So we're actually going to do 5 squared first, then multiplied by -1. So we actually have -1 times 5 squared, which simplifies to -1 times 25, and that's why we get -25. So parentheses matter. When you have a negative base, you must use parentheses. All right, number 9, if you plug this into the calculator, 1/2 squared, again, closing the parentheses, you should get 1/4. And go ahead and do 10 and 11, again using parentheses. Hopefully you got -8 and positive 16. All right, so let's fill in the chart. When we have a positive base, for example, when we have an even exponent with a positive base, so let's look at maybe 2 squared, or 5 to the 6th power, our answer is always positive. If we have a negative base, like -2 squared, or -5 to the 6th power, if you do those in the calculator, -2 squared, of course, would be 4. -5 to the 6th power is a huge number, 15,625, but they're both positive. An odd exponent, let's say I have 2 to the 3rd power with a positive base. Well, sure, that's always positive. But what if I have -2 parentheses to the 3rd power? Plug that into your calculator. I got -8. Well, guess what? When you have a negative base with an odd exponent, your answer will always be negative. Those are some rules that you can keep in the back of your mind. All right, let's take a look at where we could apply this. A certain bacterium splits into 2 bacteria every hour. There's 1 bacterium on the slide. How many bacteria will be on the slide after 6 hours? So let's just draw this out a bit. Beginning bacterium, after 1 hour, it splits into 2. Okay. After 2 hours, will each of those split into 2? And now we have 4. The next hour, they're all splitting. Next thing you know, we have 8. So let's think about this. If it splits into 2 bacteria every hour, that's our base. And let's use this first hour as an example. Well, first hour, 2 to the 1st equals 2. So that's why I have 2 bacterium. The second hour, 2 to the 2nd equals 4. The third hour, 2 to the 3rd equals 8. Well, how many bacteria will be on the slide after 6 hours? Well, let's say 2 to the 6th. And 2 to the 6th, if you plug that in your calculator, will be 64 bacterium. How about after 8 hours? You guys try that one and then compare answers. So 2 to the 8th should be 256 bacterium. All right, another application. On a rec soccer team, in the event of a game being canceled, the coach calls 3 families. Each of these families calls 3 other families, and so on. How many families will have been called in the 4th round of calls? So before they came out with apps where you get a notification that a game is canceled or the games are canceled or practice is changed, there used to be things called phone trees. And you would do this, right? One family would call 3, the next family would call 3, and then eventually everybody is called. So how many families will have been called in the 4th round? Well, remember, we got to think about what are they being split by? Well, 3. This is the base because it's really splitting by 3. Each family is calling 3 families. And on the first round, they call 3 families. On the second round, they call 9 families. Well, what happens in the 4th round, which would be your exponent? 3 to the 4th means that 81 families would be called. And please add these problems to the right side of this problem. 2 to the 0 power, 3 to the 0 power, negative 17 to the 0 power, negative 2,152 to the 0 power, and then you can conclude with the word base to the 0 power. Take a second to copy those down. All right, now, if we put those into the calculator, anytime we have a 0 exponent, we should get the number 1. Go ahead, hit pause, and complete the rest. Do 3 caret 0. So 3 caret 0, enter. Hopefully you got 1. Same thing with negative 17 to the 0 power. Any base raised to the 0 power equals the number 1. All right, that concludes section 1-4, powers and exponents. Thanks for watching.